Hello, this is Dr. Hanaa Assil, and these are questions and answers on organic chemistry. This is the basics of organic chemistry. So let's take a look at some questions. So this first question says, the structures of 3 compounds are shown. Why do these compounds all belong to the same homologous series? Remember, we said we divide organic compounds into different groups, but we do not refer to them as groups. We refer to them as homologous series. So all of these belong to the homologous series, which we call alkenes, because they all contain the same functional group. If I see double bond in the molecule, I identify it as an alkene. So all of these are alkenes because they all contain the same functional group. Then this question says, which structure is incorrect? And we should know that since carbon is in group 4, it needs to have 4 bonds. So each carbon must have only 4 bonds coming out of it. If it has more or less than 4 bonds, then the structure is incorrect. So which of these is incorrect? It is the one in which the carbons have a total of 5 bonds. So each of these carbons has 2 bonds to the next carbon and 3 bonds to 3 hydrogens. So that's a total of 5 bonds. That is not correct. Okay. Which molecular structure shows hexene? Well, even if you don't know what hex is, well, all of these choices have 6 carbons. But ene means what? You should realize that ene means an alkene with a double bond. So the structure that is hexene is the one that has a double bond between carbons. Methanol and ethanol belong to the same homologous series. What does this mean? What do we mean when it belongs to the same homologous series? Again, we said methanol and ethanol are both alcohols. And alcohols must have an OH group, that is the functional group. So they belong to the same homologous series because they have the same functional group. Which statement about alkenes is not correct? Well, what do we know about alkenes? We know that they have a double bond, so the functional group is a double bond, so A is correct. And we know that they are all one homologous series. But when he says the structural difference between one member and the next is CH3, no, the difference between each of them is CH2. Now, when he says they turn aqueous bromine from brown to colorless, that is correct. Remember, the test for alkenes is that they change, add bromine water, the color changes from reddish brown to colorless. So the one that is not correct is the one that says the difference is CH3, because actually the difference from one member to the next is CH2. Which structure is correctly named? Let's take them one by one. A. Is A correct? The question says A is called ethanoic. No. Remember, eth means 2 carbons and A has 3 carbons. So actually that is propanoic acid. What about B? B says ethene. Ene must have what? Alkenes must have a double bond. So that's not an alkene. What about choice C? Choice C says it has 2 carbons, so that's F. It has an OH functional group, so that is an alcohol. So when we say the name is ethanol, that is correct. What about D? D says its name is propane. No. Ane means alkane, and they should all have a single bond. This one has a double bond. So actually this is propene, not propane. So the answer here is C. Which of the following is an alkene? Well, how do I know? You should know that alkenes general formula is CnH2n. So the alkene is the one that has hydrogen twice the carbon. So of course that means that my answer here is C3H6. Which row is correct for ethanol? What do we know about ethanol? Ethanol is an alcohol and all alcohols burn. So when we say it burns, yes, ethanol burns. Is it made by fermentation? And remember that when we burn ethanol, we either burn it in excess oxygen to give carbon dioxide plus water, and this is called complete combustion, or we burn it in lack of oxygen or in limited oxygen, and that is called incomplete combustion. In that case, it will give carbon monoxide, which is poisonous, plus water. So, ethanol burns, that's correct. What about made by fermentation? How did we prepare ethanol? We said ethanol can be prepared either by adding water to ethene, and that is hydration of ethene, and remember the conditions: phosphoric acid catalyst at 300 degrees Celsius, or by fermentation, in which we add yeast to glucose to change it to ethanol. So yes, ethanol can be made by fermentation. Which products are obtained by the cracking of an alkane? What is cracking? Remember that cracking is the breakdown of long chain hydrocarbons into shorter chains. And what are the conditions? We should give it aluminium oxide catalyst and 400 to 700 degrees Celsius. What do we get? What are the products of cracking of an alkane? You should remember that cracking, I can break the alkane up into an alkene and an alkane, or an alkene plus hydrogen. So I can get alkene and hydrogen. But does cracking produce water? No. We don't have water formed when we do cracking, so my answer here is B. A chemist carried out a cracking reaction on a hydrocarbon and obtained two products, Y and Z. The chemist then wrote the following statements. Which of these statements are correct? Remember we said if we have X, that is an alkane, it's a long chain, and I'm going to break it up. And when we break it up into Y plus Z, then the Y plus Z, the total number of carbons and total number of hydrogens, that is what is in X. So if we say a molecule of X has 7 carbon atoms, is that correct or wrong? Well, Y has 4 and Z has 3, and that means the original one must have had 7 carbon atoms, so that is correct. Y is unsaturated. What do we mean by unsaturated? We said unsaturated means it has a double bond. So actually Y is saturated. It is Z that is unsaturated. So the one that has double bond is the one that is unsaturated. So when the question says Y is unsaturated, that is wrong. Z will decolorize bromine water. Again, Z is an alkene, and we said what is test for alkene? Add bromine water, it turns from reddish brown to colorless, so this statement is correct. This has a double bond, it is an alkene, so it will decolorize bromine water. So which statements are correct? That is statement 1 and 3. A compound takes part in an addition reaction. What does its name end with? Or how does its name end? Remember, what does addition? Any alkene does addition. So if I have ethene and I add bromine water, we said test is bromine water. So if I add bromine, what happens is the double bond opens up and becomes a single bond, and I put bromine on the carbons that had the double bond. So the one that does, this is what we call an addition reaction. The one that does an addition reaction is the alkene, so it is the one in which the name ends in -ene. The diagram shows first 4 members of a homologous series. What is the difference in the molecular formula between one member and the next? Well, if you look at it, you should realize that whether we're talking about alkanes or alkenes, each successive member of the homologous series, we're adding a CH2 to the first one. So CH4, add to it CH2, it becomes C2H6. Add another CH2, it becomes C3H8, and so on. So members of alkanes and members of alkenes, they differ from one member to the next with CH2. Ethanol can be manufactured from substance X. Again, we said, how do we make ethanol? One of the methods of making ethanol is hydration of ethene, adding water to ethene. So water at 300 degrees Celsius is in the form of steam. So when we say X plus steam to give ethanol, that means I want to add water to something to give ethanol. That something is ethene. So that when I add water, the double bond opens up and we put an H on one carbon and then OH on the other. Please remember the conditions for hydration of ethene: phosphoric acid catalyst, 300 degrees Celsius. A hydrocarbon X is cracked to make Y and hydrogen. Compound Z is formed by addition polymerization of Y. So what is X, Y, and Z? Remember that if I'm starting with a hydrocarbon X, then this hydrocarbon is ane or ene. It's an alkane or an alkene. In cracking, we're starting with an alkane. So that X is an alkane. And then when we break it up, we form either alkene plus alkane or alkene plus hydrogen. So the question says it's going to make Y plus hydrogen. That means Y must be an alkene. Now compound Z is formed by polymerization of Y. Yes, we take alkenes and we use them to make polymers. But when we make the polymer now becomes an alkene. So when we make polymers, we're starting with alkene, but when we join many alkenes together to form a polymer, that polymer is actually saturated, or it is an alkene. So my answer here is C. Organic compounds may have names ending in ane, ene, ol, or oic acid. How many of these endings indicate the compounds contain double bond? Which of these contains double bonds? You should remember alkane, no double bond, they're all single. Alkene will have double bond between 2 carbon atoms. Will the alcohol have double bond? No, an alcohol has OH. But an acid has a double bond between the carbon and the oxygen. An acid must have C, double bond O, single bond OH. So how many of these contain double bonds? It is the alkene and the acid. The table shows composition of natural gas. What is X? Remember we said natural gas is a fuel, and we said natural gas is mainly made up of methane. Natural gas is a gaseous fossil fuel, and it is mainly made up of methane. So my answer here is C. Are we following? Okay. The diagram shows some properties of 2 organic compounds, X and Y. What are X and Y? Well, let's take a look. X is something that I can use to make polymer, and it is something that reacts with bromine, and we said anything that reacts with bromine must be an alkene. Remember bromine water, adding bromine water, turning it from reddish brown to colorless, that is test for alkene. So X is ethene, not ethane. And then the ethene, we said I can do hydration. So I can add water to the ethene to form ethanol. If I add water to ethene, it forms ethanol. So X, it says it reacts with bromine. Yes, we said X must be an alkene because alkenes react with bromines and change the color from reddish brown to colors. Now, we also know that alkenes react with water to form what? To form the corresponding alcohol. So ethene will react with steam and a catalyst to form ethanol. So my answer is D. The diagram shows part of a polymer. Which compound is used as the monomer? I'm going to remind you that monomer is the small molecule. We have many of them, and we join them together to form a long chain, and the long chain is what we call polymer. Now, when we're given the structure of polymers, then we don't look at all of these carbons. We look at the first two, because this is what was the monomer that is being repeated many times. Now, going from polymer to determine what was the original monomer, we remove the bonds on both sides and we put a double bond in the middle. So obviously this polymer was made from ethene, which is C2H4. This question says the diagram shows 3 repeat units in the structure of an addition polymer. Which alkene monomer was used? Again, when we have the polymer, we look at the 2 carbons at the beginning because this is the unit that is being repeated. We remove the bonds on both sides and we put a double bond in the middle. So this one is similar to which of these? It is similar to the one drawn in C. 1 carbon on one side has bonds to 2 hydrogens, the other one has bonds to 1 hydrogen and 1 Cl. Whether it's up or down does not make a difference. Which properties of the different compounds in petroleum enable its separation into fractions? I'm going to remind you that petroleum is a mixture of liquids, so when we separate them, we separate it first by fractional distillation. Now, that means that the different fractions are separated based on differences in boiling point and differences in chain length, because we said the ones collected at the top are the ones with less number of carbons, low boiling point. So these are the factors that determine where is the fraction we're collecting. So this is 1 and 2. Petroleum is a mixture of hydrocarbons which can be separated into fractions using fractional distillation. Which fraction is used as fuel in jet engines? Again, you are required to know the order in which the fractions come out and the uses of each one. So, which one is used as jet fuel or fuel for jet engines? That is kerosene, and remember that kerosene may also be referred to as paraffin oil. This question says in an oil refinery, petroleum is separated into useful fractions. What are X, Y, and Z? Well, you should know the order in which these are obtained. So, refinery gases is the one on top, then gasoline is below it. Now, what is X? X is something between gasoline and diesel oil, so it could either be naphtha or kerosene, which is paraffin. So my choice from the answers is C or D. Then we have diesel oil and then Y and then Z. So Y is something below diesel oil and Z is at the bottom. So that means we're looking at fuel oil and B to me. Increasing the number of atoms in one molecule of a hydrocarbon increases the amount of energy released when it burns. So what is the correct order? That means we want to start from less energy, that means less number of carbons. So the choices I have are ethene, ethane, methane. Which of these has less number of carbons? You should realize that methane has less number of atoms than ethene, and ethene has less number of atoms than ethane. So ethane is the one that will give the more energy released when burnt. What is petroleum? Remember we said petroleum or crude oil we regarded as a mixture of hydrocarbons. Petroleum is a mixture of hydrocarbons. Bitumen is a substance obtained from fractional distillation of petroleum. Can you see where bitumen is? It is the very last fraction at the bottom. Which row describes its boiling point and size of its molecules? Remember we said in the fractionating column, the ones at the top are the ones that have less number of carbons, lower boiling point. So if I'm looking for the one at the bottom is the one that has high boiling point and large size of molecules, many number of carbons. The table shows composition of 4 different types of petroleum. Which type of petroleum is best for the motor vehicle industry? You should realize that the motor vehicle industry will use which of these more? The cars use more gasoline. So the one that is better for cars or motor vehicle industry is the one that has a higher percentage of gasoline. So which of these types has more percent gasoline? That is the one that is referred to as North Sea. So this is the highest percent of gasoline. Most objects made from synthetic polymers last for many years. Why do polymers last for so long? Remember, the disadvantages of polymers or the problems of the use of polymers is they are non-biodegradable, and we said that means the bacteria cannot break it down, so they cannot be broken down by bacteria, and therefore they accumulate in dump sites. And then when we decide to burn it, they release toxic gases. So remember that they are non-biodegradable because they are chemically unreactive or they are chemically inert. So when the question says they are chemically unreactive, yes. Are they biodegradable? No. Remember we said they are non-biodegradable. So my answer is C. The structure of compound G shown. G is in the same homologous series as ethanoic acid. So this is a carboxylic acid. And I'm going to remind you that carboxylic acids do exactly the same types of reactions that are done by normal acids like hydrochloric acid, nitric acid, sulfuric acid, and so on. So this is an acid. Now, does it produce a gas with magnesium? You should know that magnesium is a reactive metal. It reacts with acids in general to give hydrogen gas. So yes, it reacts to give a hydrogen gas. What about its effect on methyl orange? So remember that acids react with metal to give something, which we call a salt, plus hydrogen gas. And what is the effect of acids on methyl orange? Remember that methyl orange in acid, it is red. So the question says, does it turn methyl orange yellow? No. Methyl orange in base is yellow. But in an acid like this acid, which is actually propanoic acid, it will turn methyl orange to red. So my answer here is C. Which row shows properties of methane? Again, you should know that methane is an alkane. It is actually the first member of alkanes. Would you expect methane to dissolve in water? No, actually alkanes or hydrocarbons in general do not dissolve in water. What about its state at room temperature? You should realize that if we're talking about alkanes, the first few carbons are gases. So alkanes with 1 carbon or 2 carbons or 3 carbons or 4 carbons, methane, ethane, propane, butane, all of these are gases. As the number of carbon atoms increases, then they become liquid and then they become solid. Would it give a positive test with bromine? We said, what gives a positive test with bromine? It is something that has a double bond. Alkenes are the ones that give a positive test with bromine and change it from reddish brown to colorless. But methane would not give a positive test with bromine. Are we following? The formula of 5 compounds are listed. Which compounds are in the same homologous series? Again, we said, if they are in the same homologous series, that means they should have the same functional group. Now, which of these have the same functional group? Remember, alkanes, alkenes, alcohols, acids. You should know the functional group of each one. And you can see that compound 2, 3, and 5 all have an OH, and that means they are all alcohols and they all belong to the same homologous series. Which process is used to make an alkene from a long chain alkane? You should realize that cracking breaks up long chain hydrocarbons into shorter chains. And we said cracking, the conditions are, you have to know conditions for the reactions that have specific conditions like cracking. You should know that we need aluminum oxide catalyst and 400 to 700 degrees Celsius to break the long chain into shorter chain, which could be an alkene or an alkane, or it could form alkene and hydrogen. Complete the following statements using these words. Well, let's see. Organic compounds usually contain atoms of what? You should know that organic compounds all contain carbon and hydrogen. Each homologous series contains compounds with all members of the same homologous series would have similar chemical properties. They will do the same types of reactions due to the presence of the same functional group. The compound shown is the first member of alkane. State 2 characteristics of a homologous series. We said, what is meant by homologous series? It's a group of organic compounds having the same what? Having the same general formula and the same functional group. Name and draw the structure of the next member. When we say next member, that means you add another carbon. So instead of having 1 carbon, I want to draw the alkane with 2 carbons. So that is ethane. Remember that any organic compound with 2 carbons, the name will start with S. It's an alkane, so it is ethane. Remember, alkanes have only single bonds, and then you have to complete the structure with bonds going to hydrogen so that each carbon cannot have more than 4 bonds. Okay, complete the table. Ethene, it tells me C2H4, that's correct. What is the structure showing all atoms? We said ene means it must have a double bond between the carbons, and then we complete it with hydrogens so that each carbon cannot have more than 4 bonds. So you cannot put another hydrogen on each carbon or it would have too many bonds. What do we use ethene for? You should know that we use ethene to make polymers or to make ethanol. We use ethene to make polymers or to make ethanol. Ethanoic acid. How do we draw the structure of ethanoic acid? Ethanoic acid, Eth means 2 carbons. Oic acid means on the last carbon you must put double bond O, single bond OH. Then we're given this. dibromoethane. What is the molecular formula? You have to remember that the word molecular formula means we're going to collect all the total number of carbons, total number of hydrogens, and total number of bromines in this case. So the molecular formula of this is C2H4Br2. Please note that we put the carbon first, and then the hydrogen, and then anything else. Do not say it's H4C2. That's not how we write formulas of organic compounds. Organic compounds, carbon first, then hydrogen, then anything else like oxygen or bromine and so on. What is the name of CH4? You should realize that this is methane. It has one carbon, so its name must start with meth. It has only single bonds, so it is an alkane, so its name is methane. What do we use methane for? Remember, we said that methane is the main constituent of natural gas. And what do we use natural gas for? Fuel. So when we're required to write what do we use methane for, don't say as natural gas. We don't use it as natural. It is natural gas. And what do we use it for? We use it as a fuel. What is meant by hydrocarbon? Remember, the word hydrocarbon means organic compound having carbon and hydrogen only. Please do not forget the word only, because all organic compounds have carbon and hydrogen. But if they have carbon and hydrogen only, nothing else, no oxygen, no bromine, no nothing else, then it is a hydrocarbon. Explain why this hydrocarbon is an alkane. So it is giving me C8H18. Why do we think it's an alkane? You should remember the functional group of alkanes. The functional group of alkanes is single bond. Now, what about the general formula? The general formula of alkanes is CnH2n plus 2. And that means if it's an alkane, the number of hydrogens should be twice the number of carbons plus 2. So C8, twice of 8 is 16, plus 2 is 18. This follows the general formula of alkanes. Methane, ethane, propane belong to a particular homologous series. State the name of the homologous series. Of course, if we're talking about methane, ethane, propane, then all of these belong to the homologous series called alkanes. Alkanes are a homologous series. Name another homologous series of hydrocarbons. We said which ones are hydrocarbons. The ones that we talk about are alkanes and alkenes. Remember, alkanes and alkenes are the hydrocarbons we have in the IGCSE syllabus. Okay? Draw the structure of methane. Again, if we're required to draw methane, you should remember meth means one carbon. And then ane means we have only single bonds, and we have to complete it so that each carbon has a total of 4 bonds, so we need 4 hydrogens. Which one of the following compounds belongs to the same homologous series as methane? Again, we said methane is an alkane. General formula is CnH2n plus 2, and that means if it's an alkane, the number of hydrogens should be twice the number of carbons plus 2. Alkanes are following the general formula CnH2n plus 2. So which of these is hydrogen twice the carbon plus 2? That is, of course, the C2H6, which is ethane. What is meant by cracking? Remember definitions. What is meant by cracking? You should remember. Cracking is the breakdown of long chain hydrocarbons into shorter chains using heat and catalysts. We said we start with a long chain and we use heat, 400-700 degrees Celsius, catalyst, aluminium oxide catalyst, and we break it up into a shorter chain. Now complete the equation for cracking of propane. We said cracking can either give alkene plus alkane or alkene plus hydrogen. So here we're just removing H2. So we're left with what? We started with C3H8. We're removing H2. And that means we're left with C3H6. It's just the rest of the carbons, the rest of the hydrogens. Complete the following equation for burning methane in excess oxygen. Again, we said combustion of a hydrocarbon like methane will give what? It will give carbon dioxide plus water. This is what we call complete combustion in excess oxygen. This gives carbon dioxide plus water. Please do not forget to balance any symbol equation that you write. So here, in order to balance, we need a 2 in front of the O2 to balance the number of oxygens, and the rest is balanced. Many of the compounds obtained from petroleum are alkanes. Which two of these are alkane? Of course, we said alkanes means they have only single bonds. General formula CnH2n plus 2. That means number of hydrogen should be twice the number of carbons plus 2. So which of these are alkanes? Of course, A and D are alkanes. B is an alkene and C is an alcohol. Use words to complete the sentence. Alkanes such as, which of these is an alkane? Alkanes such as ethane are generally unreactive. Remember that alkanes are not reactive, not very reactive. They do only a few reactions. Alkenes will do many more reactions than alkanes. So we say that alkanes are generally unreactive. But they can be burnt. So one of the reactions that they do is combustion. And they can be burnt in what? When we burn it, it reacts with oxygen to form carbon dioxide and water. Alkanes are saturated hydrocarbons. We said, what do we mean by saturated? Saturated means they have only single bonds between the carbons. No double bonds between the carbons. What does hydrocarbon mean? They have only carbon and hydrogen. Only. Steam reacts with ethene in presence of a catalyst. Remember we said I can add water at very high temperature, so that is steam. I add it to ethene to prepare what? We said this is one method of making ethanol. This is hydration of ethene. Do you remember the conditions? Phosphoric acid catalyst 300 degrees Celsius. This will give ethanol. Ethanol is formed by catalytic addition of steam to ethene. Complete the structures of ethene and ethanol. How do we draw ethene? You should know that S has 2 carbons. And we complete it so that the carbon has no more than 4 bonds. Now ethanol. Ethanol again has 2 carbons, but the ol means it's an alcohol, and alcohols must have OH. Remember the question says showing all atoms and bonds, so this is ethanol showing all atoms and bonds. This is what we call a displayed formula. What do you understand by the term organic compound? What does organic compound mean? You should know that organic compounds are covalent compounds of carbon that were originally obtained from plants or animals. Some organic compounds are found in fruits. Which two of the compounds belong to the same homologous series? Which of these belong to the same homologous series? Remember, same homologous series means they should have the same functional group, and that means B and C, because the CO2H is COOH, or C double bond O, single bond OH. These are carboxylic acids. Which one of these compounds is unsaturated hydrocarbon? Remember, we said unsaturated means It has a double bond between the carbon atoms, so that is A. Which one of these is an alcohol? We said alcohols must have what? Alcohols must have an OH, so the one that's an alcohol is D. Which one of these compounds can be formed directly by cracking of something from petroleum? We said cracking will give what? Cracking gives alkene plus alkane, so A. Okay, ethene can be polymerized to form polyethene. Complete the equation below to show the structure of two units. Remember that each of these is referred to as one unit. Now, if we form polymers, we said, how do we form polymers? The double bond is opened to form a single bond, and we make a bond on the right and a bond on the left to join to the next unit. Here we have two units repeated, so this is the structure of the two repeat units. Of course, what is the name of this type of polymerization? Remember that this type of polymerization is called addition polymerization. When we start with alkenes and the polymer is the only product, then this is addition. Again, we said petroleum is a mixture of hydrocarbons. In order to obtain the different fractions, we said we do fractional distillation. So which of these fractions has the lowest boiling point? You should remember that the one on the top is the one that has the lower boiling point. Now, if the question says describe how distillation is used to separate these fractions, remember what happens is the crude oil or the petroleum is heated and then vaporized. Then it is cooled and condensed in the fractionating tower to give different fractions at different what? We're separating them based on differences in boiling point. And remember that the one with the lower boiling point is collected at the top. You should know the uses of each of these. So what do we use paraffin for? Remember, paraffin is the same as kerosene. We said we use it as fuel for jets. And butamine is the fraction at the bottom, and that is used for road making. And this is the end of this video. I hope organic chemistry is now a little bit better. This is the basics of organic chemistry, and we have other videos to explain the other topics in organic chemistry. Thank you for listening.